Hi everyone. In this video we're looking at a full wave rectifier, and it's of the center tapped configuration. So we're going to look at two full wave rectifier circuits, but the first one is what we call the center tapped version. So the primary side of the transformer is here. On the secondary side we have what we call a center tap, and that means that we can use the full secondary, we could use half the secondary, and you'll see why having the center tap becomes important in this configuration. So this configuration for a full wave rectifier uses two diodes from top and bottom of the secondary. Both of those diodes then join together and go to a load resistor reference to ground. That ground point is also where the center tap is connected to. So I could have just tied the resistor back to the center tap, but often we draw it out to the side, especially if we're going to put a filter capacitor on there. So just keep in mind when you're looking at this circuit that this ground and this ground are connected together. Okay? So let's look at what happens for this circuit when we have the AC signal input. On the secondary side, that gives us a positive cycle and a negative cycle, so I've color coded them. So on the positive cycle, the polarity across the full secondary is like this. Okay, and remember that positive is more positive than ground. Ground is more positive than negative. Okay, if you're looking at a number line where you have +1, 0, and -1, think of 0 as the ground. That is bigger than -1. But 1 is bigger than 0. 1 is also bigger than -1. Okay, so when we're thinking of the polarity and whether or not a diode will be biased, we want to keep that arrangement in mind. Okay, so looking at this positive cycle, this diode will be forward biased. This diode down here will be reverse biased. So this diode is going to be on, this diode is going to be off. Okay, so the flow of current then is going to be through this diode, through the load resistor in this direction, and then back through the ground to the secondary like this. So you can see that that this load voltage out that we get is only from half the secondary. So this VL in this direction, we're going to get this for the positive cycle, but VL peak is going to be equal to the secondary peak divided by 2, because it's returning to this half of the secondary, right? We're only using half the secondary, minus the 0.7 volt drop of the diode. Okay, so we have to consider that that diode drop. So that's this VL peak, is that peak voltage. So let me redraw that current path in red so I stay color coded. So that is going like this, through the load in this direction, which is very important, back through the ground like so. Okay, because remember those two ground points are actually connected together. Now for the negative cycle, the polarity reverses. The polarity reverses and we have this polarity across the secondary. So this diode is reverse biased and it's off. This diode becomes forward biased and it's on. So current then is going to flow this way through the load resistor in the same direction as before, which is really important, back through the ground, and then cycling back this way. So you can see that it's using the other half of the secondary. So again, the VL peak is going to be the secondary peak divided by 2, because it's using the other half of the secondary, minus the drop on that diode, and we get an output like so. So it has the same VL peak for both cycles. And then if we have a positive cycle again, this just repeats. So in this way, using 2 diodes and the center tap, we can, instead of cutting off that negative voltage from the primary, we can flip it up and have it become positive. So now we have more DC voltage. We don't have these areas of 0 DC voltage, and that is a clear advantage. The only downside that we have to remember, or I mean, it could be a positive if you actually wanted your voltage to go down, is that we only have half the voltage across the secondary minus the diode drop. We don't have the full secondary voltage anymore. If you actually wanted to drop the diode, if you actually wanted to drop the voltage down even further like that, that might be a particular advantage actually, but it's a distinct difference that we need to keep in mind for this circuit.